Welcome. The question before us says a sand sample of 35 cm square cross-sectional area and 20 cm long was tested in a constant head permeameter under a head of 60 cm. The discharge was 120 milliliters in 6 minutes. The dry weight of the sand used for the test was 1,120 grams and GS, which is our specific gravity, equals to 2.68. It says determine hydraulic conductivity, the discharge velocity, and the seepage velocity. Okay, how do we do this? Let's first of all say solution. So we say solution. First of all, we want to look for our hydraulic conductivity, which is K equals to discharge over area times hydraulic gradient times time. So, but our hydraulic gradient is also head over length of sample, and therefore substituting that value, we have K to be equals to QL over AHT. Good. And we've been given our values as Q equals to 120 ml. We've been given T equals to 6 minutes and A equals to 35 cm square and L equals to 20 cm or more, and H is equals to 60 cm. So now inserting those values into our formula that has been established, we have K equals to 120 times 20 all over 35 times 60 times 6 times 60 to take it to seconds, and we end up with 3.174 times 10 raised to power minus 3 cm per second. That is for our hydraulic conductivity. So now we are also asked to find our discharge velocity. Oh, discharge velocity. So discharge velocity. Let us denote it with VD so that we can um, differentiate it from other forms of velocity. So our discharge velocity VD equals to Ki, that's hydraulic conductivity, um, um, hydraulic gradient. So recall that our hydraulic gradient I Now hydraulic gradient I equals to H over L. Okay, so now our VD equals to K dot H over L, which is equals to 3.174 times 10 raised to power minus 3 times the value of H, which is 60, over the value of L, which is 20, and we obtain our value to be 9.52 times 10 raised to power minus 3 cm per seconds. That was beautiful. So now we are also asked to look for our to find the seepage velocity. Seepage velocity. Seepage velocity, let us denote it with Vs, which is equals to your discharge velocity all over porosity. So to obtain this, we need to do some kind of relationship, for us to be able to get our porosity. We have to look for our void ratio, our dry density, So now we start by saying, okay, we have a dry density to be the dry weight of the soil over the volume of the soil, which is equals to one, which we were given as 1120, all over the volume of the soil, which is the area, times the length of the sample, which is equals to 1.6 grams per cm cube. Wow, that was beautiful. So let's move to another slide. Um, Again, we have this relationship that relates dry density to void ratio and specific gravity. So our unit weight of, which is the unit weight of water times specific gravity over void ratio plus 1 plus your void ratio. And our void ratio, if we recall, if we make our void ratio the subject of formula, we have our specific gravity over dry unit weight minus 1. So, and if we recall, the unit weight of water is 1 gram per cm cube. So now our substituting these values into this relationship, our specific gravity, we have it to be 2.68 all over our dry unit weight, which we have calculated 1.6 minus 1. Oh my God, what did we do? 1.6 minus 1, which will give us 0.675. So now our porosity N, we know we have a relationship of porosity with void ratio, and that is E over 1 plus E. Void ratio over 1 plus void ratio, which is equal to 0.675 all over 1 plus 0.675, which gives us 0.403. And therefore our seepage velocity Vs, let me say therefore seepage velocity Vs equals to, which you will recall is our Vd over N, which is equals to 9.5 times 10 raised to power minus 3 all over 0.403, which is equals to 2.36 times 10 raised to power minus 2 cm per second. Wow, that was beautiful. So the PDF, um, the PDF, the PowerPoint copy of this solution will also be attached to the video. So you can also download it. So you for your so you can use it as well. Don't worry, it's free. Hooray! Okay, we've come to the end. Enjoy yourself, learn well, subscribe, like, share.